All right, guys, so up until this point, we've talked only about standard form when we are dealing with the quadratic equation, the quadratic function. Today, we're going to talk about, or right now, we're going to talk about vertex form and what that looks like and how transformations take place from vertex form. So when we're talking about vertex form, we have an equation here. It's y is equal to a times x minus h squared plus k, all right? And it creates a parabola just like our y equals ax squared plus bx plus c. It's the same thing. Our a is still the same, right? If our a is negative, it flips. The smaller a is, the more narrow it is, the bigger it is, the wider it is, right? But what's different about this is we have our h and our k, all right? And I want to point out this is x minus h, okay? And our h and our k is where our vertex is in this form, okay? So when we're talking about transformations, it's easy to see transformations that take place from vertex form, okay? Our A will show us a reflection or a stretch or compression, okay? And then our H and K will show us if it moves left or right or up or down, right? Change in our H will move it left or right, and our change in our K will move it up or down, okay? And we're going to go over an example of this, okay? So we have y is equal to x squared, and you can see it here, actually. Let's look here. Our A, as it gets bigger, right, it compresses as it gets bigger, as it gets small, or sorry, it stretches as it gets bigger, as it gets smaller, it compresses, and if it becomes negative, it flips over the axis, right? And then also with our H will move it left and right. So if our H changes, it will move left or right. And if with our K, it will move up and down, okay? Our K will move it up and down. All right, so if we're looking at this question here, x squared compared to negative 3 times x plus 4 squared plus 2. Okay, if we're looking at this question here, our green one here is x squared, which is what we've been working with so far. Okay, the negative 3, as we can see, it flips it over the x-axis. Okay, the 4 moves it to the left 4 units. The 2 moves it up 2 units, and then the 3 also compresses the graph by a measure of 3. Okay, it also compresses it by a measurement of 3. Okay, so let's look here at that question. Okay, if we look here, question 5 is what it's asking for. Okay, reflects across the x-axis. We said it's stretched by a factor of 3 units. Translate 4 units to the right. No, it translated 4 units to the left. Okay, 4 units to the left. Stretch by a factor of 3, reflect across the x-axis, translate 4 units to the left, and 2 units up. So that question would be D, okay? And I just want you to be able to draw I want you to be able to see that in the question, okay? Question number 6 here, it's talking about negative 2, and we're looking this equation here, and we're looking for the vertex, axis of symmetry, min, max, and domain and range, okay? So let's look at this question real quick. Okay, and it's right here, okay? And as we know, this is our vertex, so we can write that down, right? We can write our vertex down. Our vertex is negative 7, comma, negative 3, okay? It's also in our equation, right? Negative 7, comma, negative 3, right? We just have to flip that sign. Now, our axis of symmetry is whatever the x value is of our vertex, so x equals negative 7. Now, is that a maximum or minimum? Well, this is the highest point on the parabola, so that would be the maximum, okay? And the maximum point is y is equal to negative 3. It's that y value, okay? Domain is always, unless otherwise specified, is all values of x. And our range, in this case, is y. And because it's a maximum, right, then it's going to be less than or equal to negative 3. All right? That is a maximum. Y is going to be less than or equal to negative 3. So that is question 6. Question 7 is exactly the same. I want you to walk through question 7. Okay, and then I'm going to come back and I'm going to walk you through questions 8 and 9 in the next video.